Thomas Edison was one of the most prolific inventors of all time, holding 1,093 U.S. patents in his name, as well as patents in the United Kingdom, France, and Germany. And he's credited with numerous inventions that contributed to mass communication, in particular telecommunications, including the stock ticker, a mechanical vote recorder, a battery for an electric car, electric power, recorded music, motion pictures, in addition to things that everybody recognizes like the light bulb and sound recording. But historians would argue that his greatest contribution was actually none of these, but the development of the modern research laboratory, where he brought together the best scientists and engineers to plan and carry out investigations. It was these teams, these people working collaboratively, that came up with the numerous inventions for which Edison is credited. And in the Next Generation Science Standards, in Dimension 1, Part 3, discusses planning and carrying out investigations. And CSCS is a way to help people come together and collaborate to do things that they couldn't do individually. And in this way, it harkens back to Edison's research laboratory, only now we can work both in entire classrooms and across classrooms and in cyberspace to plan and carry out investigations that no one individual could do in the same time. In the CSCS rocket activity, students are asked to design and conduct investigations into the rocket propulsion, and basically challenged to get a rocket that'll travel farther and higher than their peers. In particular, they're looking at two additional questions. What is the influence of reaction mass on the height that the bottle will go, and what is the influence of reaction mass on the maximum velocity, which requires they have to do some video analysis. So in this case, CSCS is really great for aggregating people's work. So each person basically started off by analyzing the behavior of a basketball and using video physics to do so. And you can see here that when a basketball is thrown, this is one person's graph. You can see that there's a lot of others that were contributed here. And you can just see that basically as you go through the list, that everybody is using the same software, but it requires them to individually identify the spot that the projectile is at any particular point. And you can see again a tremendous similarity in the various different graphs. Again, they're all following parabolic trajectories as you would expect. So the CSCS allows them to confer with their colleagues to see if they are doing the right type of measurements and the right type of design before they go very far. In addition, you use CSCS to collect images of their designs. So you can see here these are some designs of some of the 2-liter bottles. Each group has kind of their own individual design for it. And then they can test those designs using the video physics application. So they take their cell phones and they video a rocket taking off. You can see one right here taking off. You might see that right there is the rocket itself. This is done with slow motion photography. And so as this object is falling down, they're tracking it with their cell phone, and they're trying to determine the height that it's gone, the velocity from takeoff, and again trying to get the rocket that not only goes the highest and farthest but also travels the fastest. So looking at design and looking at the data from the various different designs. So when they analyze their graphs using video physics, they get a variety of different diagrams or plots. You can see them here, but they have the same basic patterns if you're looking at the same individual idea. So if I was to click on this one right here, for example, you can see it's they're plotting the X and the Y position, looking at its trajectory. and figuring, the elevation that this has gone up. So that one's going up only about 30 meters, and they can compare their results. But also, you may notice that some of these vary dramatically from the other ones, and sometimes they were just had poor technique, as in a case like this. And by analyzing theirs in the context of whole class data, they can realize, hey, wait a minute, maybe the data that I collected wasn't really very good, and then they would have to run the activity again to collect better data. So the CSCS approach of pooling data and being able to compare and contrast designs allows students to better plan and carry out investigations.